Hey guys, it's Mrs. Pope from Roger Bacon High School, and I am going to work on some of the problems that you gave me for the Chapter 5 review for our test on Thursday. Hopefully you enjoyed your half day after testing. I'm sure nobody's looking at this before then. And you're getting ready to prepare for our test on Thursday. Most of the problems I was able to do, I'll be able to do. Some of them I can't because you can't see the graphing calculator or the problem in the book if it's pertaining to a graph. So when I get to those, I'll just tell you, hey, see me early on Thursday in class if you still want me to look at that. All right, let's just go ahead and get started. The first one I'm going to do, I'm doing them in chronological order from pages. So the first one I'm going to do is from page 328, and it was number 57. So if you want to take a moment, follow along in your book, open up to 328, and the question was on, where is it? Number 57. All right. So it says, describe the end behavior of the graph of each function. Well, if you graph this in your graphing calculator, if you want to do that, pause the video now and do that, and then come back and we'll talk about the end behavior. All right. Now that you're back, your graph, of course, is going to look a lot better than mine, but a general idea, it kind of looked like a McDonald's sign, for lack of a better description, something a little bit like this. Okay, so not perfect, but you get the idea. Yours look better on your screen, but we can answer the question just the same. So the end behavior is talking about what is happening to the function as I'm traveling all the way to the left, because this is the end, and what's happening as I'm traveling all the way to the right, positive infinity. So let's start looking to the left. As x is approaching negative infinity, that means as I'm traveling along my function all the way to the left toward negative infinity, I'm going to the left, left, left. My function is also headed toward negative infinity. Now if I want to travel to the right, so as x is approaching positive infinity, so if I'm going right, this function is also going to negative infinity. So no matter where I go, both of my ends end up in negative infinity. That's why we have two arrows pointing down. We could have told that just from looking at the equation. Since the coefficient was negative 5, I could tell that it was pointing down. And since the exponent was even, since it's to the fourth power, I could tell that they're both going in the same direction. So that could be a little shortcut. All right, let's move on. That was 328, number 57. So next question on 328 was number 63. I'll talk about it, but I can't really point or anything because I can't video the graph. So if you look at number 63, it was a squiggly line, and the question was, I think it was Shaniqua and Virginia are determining the number of zeros. Shaniqua said that there were 7. Virginia said that there were 8. Actually, Virginia is correct. If you look at the function, if you count them, even if you have a root that touches only once, we do need to count that. So if you count from left to right, and I can't point, but if you're counting with me, 1, 2, 3, 4, 5, 6. I'll show you this in class so I can actually point it out. But just keep in mind, if it only touches once on the x-axis, that means it's a double root. That would be something like x minus 2 squared. We know that has, if we did that twice, we would know that the answer would be 2 twice, but it's only going to touch the graph in one place. So that might not make a lot of sense because I'm not showing you with my pencil. If you still have questions about that, we can talk about it quickly on Thursday morning. All right, let's change pages. Let's keep going. Let's move this little guy out of the way and keep going. What's next? Page 347. Number 65. Is that a 5? Whatever it is now. Okay. Page 347, if you want to flip there quickly. Number 65. Oh, this is a fun one. We didn't really do many of these, turning them into squares, but the equation was x to the 6 minus 26x cubed minus 27 is equal to 0. And it says solve. Well, this is one of those, I remember Reggie asked about one of these in class about turning this into a square. So what we would do is we want to turn this into a square so it's a quadratic, and we can use our quadratic methods to solve it. So this x to the 6th is really the same as x cubed squared minus 26 times x cubed, same thing, minus 27 is equal to 0. Now what this has done, this is now in ax squared plus bx plus c. So I have a quadratic form technically now. So the way we're going to do this, it's going to be a little fun here, because I like to have fun. Let's make x cubed equal to happy face. Okay, you probably think I'm crazy right now, but it is probably like almost 10 o'clock, so maybe I am being delirious. But anyway, let's let x cubed equal happy face. So if x cubed is equal to happy face, I'm going to rewrite this so it doesn't look so crazy. Well, I don't know if it's less crazy if it's happy face. So if you have happy face squared minus 26 times happy face minus 27 is equal to 0. Hopefully you'll see my point here soon. If I just have one of these happy faces, now if I'm just looking at this, let's factor that. We can factor it. What two numbers multiply to negative 27 and add to negative 26? Well, negative 27 and 1. So this factors down into happy face minus 27 times happy face plus 1. And let's set that equal to 0. So if we do that, we've factored it, and we know what happy face is. That's just like a placeholder right now. So we're going to set, remember, either one of these would be the solution. If I wanted this parenthesis to be 0, then happy face is actually going to have to take a value of 27. Or if this one would be 0, happy face would have to take a value of negative 1. So my answers would be x is equal to, not x, how did I get x? It's happy face. Happy face when you need it. So happy face is equal to 27, or happy face is equal to negative 1. Now let's replace our happy face with what it actually is. So x cubed is equal to 27, or x cubed is equal to negative 1. So our answer here, of course, the cube root of x cubed would be x, cube root of 27. It's going to be 3. And our other answer would be negative 1. Hope you enjoyed the happy face. If that didn't make sense, watch it over again. Alright, moving on. Number 334, page 334, number 24. I can't really show that. If you want to flip back to check it out, if this was yours, page 324, number 24. Yeah, it says use the graphing calculator to estimate the x-coordinates in which the max and min occur. That's something I can show you again on Thursday morning if you still need to see it. But I can't really show you the graphing calculator on here. Alright, so let's move to page 375. I know we're jumping around quickly. I don't want my YouTube time to run out. So we're not going to do that. Let's look at page 375, number 36. And it is 54x cubed y minus 16y to the 4th. And I think it just says factor completely. So first I would look at this and see my greatest common factors I can take out. I can see right away I can take a 2y out, which would leave me with 27x cubed minus 8, oh isn't that nice, y cubed. Aha. If I do that, this parenthesis turns into a difference of perfect cubes. So the difference of perfect cubes, remember these are the formulas that you do need to know. If I have a cubed minus b cubed, let's change back to black. a cubed minus b cubed is equal to a minus b, I'm going to run out of space, times a squared plus ab plus b squared. Hopefully I memorized that right. So our a here is going to be 3x. Our b is going to be 2y. So we're just going to go ahead and solve this, factor it out. So don't forget our original 2y. Then, if we follow it, we should have 3x minus 2y times 9x squared plus 6xy plus 4y squared. And there's nothing else we can do from there. Again, as you're watching these, you may want to pause them, chime on your own, and then hit play to see if you get the same answer. You can use this however your heart desires. Alright, that's it from page 375. Moving right along. Page 376, number 47. Someone asked, when they wrote on the paper, anything from 5/6. Okay, so I picked something from 5/6. I picked this one, number 47. It says, and I'm not going to write it, you see it on there. If you go to page 376, number 47, it says, given a polynomial and one factor, find the remaining factors. So you're given x cubed plus 2x squared minus 23x minus 60, and one of the factors is x minus 5. Well, I'm going to divide out one of those factors and see whatever is left. That should be the other factors. Well, I'm going to use synthetic division since I have a nice easy x minus 5, so I'm going to put 5 in here for synthetic division. Line up my coefficients, 1, 2, negative 23, and negative 60. Whenever I can save time, I like doing that. So I'm going to bring down my 1 and get started. 5 times 1 is 5. Add them up, you get 7. 5 times 7 is 35. Add them up, you get 12. 5 times 12 is 60. Oh, isn't that nice? The remainder is 0. We should have known that was going to happen since they told it was a factor. But this is our remainder. This is our constant. This is our x term. This is our x squared. So we end up with x squared plus 7x plus 12. And the original factor they gave us was x minus 5. Now don't forget, you need to check and see if this can be factored. And in fact, this can. There are two numbers that multiply to 12 and add to 7. You've probably already figured them out. 3 and 4. So our final answer is going to be x minus 5 times x plus 3 times x plus 4. And this will be our final answer. Alright. Moving. Page 377. Number 8. I'm assuming this was asked before we did this in class, so I'm actually going to skip that one because we did this one in class today, so I think somebody must have written that down before we went through it as a class. But there was a question on number 16. Let's see what that is. Oh, it's about the frame. So I'll just put it in class. So number 16 is about this picture frame. The area of the picture in the frame shown is 168 square inches, 168. What's the width of the frame? Well, we need to set up the equation. We know that area is length times width. And the width of it, if you notice, it shows you that the little corners are x. So the width is going to be 8, that they tell us, the 8 inches, plus 2x for our little corners. Then our length is going to be 10 plus 2x. So if length times width equals area, then we're going to have 8 plus 2x times 10 plus 2x. What's that? And that's going to be equal to 168. So if you went ahead and foiled this, foil out the 8 plus 2x, and it doesn't matter if you had the 10 plus 2x first. Multiplication is commutative, so it could go either way. But if you foil that out, you're going to, and you get it in standard form, you're going to end up with, and you can try that, pause now, foil it, see what you get, and then come back. You should get 4x squared plus 36x plus 80 is equal to 168. Then if we subtract 168 from both sides, because we're going to set it equal to 0 and solve, we'll end up with 4x squared plus 36x minus 88. I'm going to need to, can I scoot down? Oh, I don't think I can scoot down on this one. Okay. I'm going to run out of space in my big writing. So this is equal to 0 now. I want to start factoring this. I know I can factor a 4 out right away and be left with x squared plus 9x minus 22 is equal to 0. And then this factors into, I might be able to squeeze it in, x minus 2, x plus 11. Yeah, I think I can make it. So there are two options here. I could either, remember zero product property rule, either one of these parentheses has to be equal to 0. So it's either going to be 2 or negative 11. Well, the last time I've seen inches in negative values was never. So the only one that's going to make sense here would be 2. So x is equal to 2, or the width of the frame is 2 inches. Is that what they wanted? Is that even what they wanted? Alright, let's move on. Let me check my time. Sorry about that. I wanted to check. I'm running low on, I only have a certain amount of time on these YouTube videos. So I'm trying to go quickly. Sorry, we saw for x was equal to 2, and I think the question, I don't remember if it was asking the width or the length. Oh, the width. What is the width of the frame? So our width was 8 plus 2x, so we plug 2 in for that, 4. 8 plus 4 would be 12, so our width would be 12. Alright, let's see. I think I can get maybe, oh, am I almost done? 377, number 8. Number 16. The last one was number 25. Quick. Oh, great. I can do that in like 2 seconds. Okay. Number 25 on same page 277. This was the RIT. Real, imaginary, total. So this is all we did with this type of problem. List all the possible zeros. All I wanted to know here were the real and the imaginary. So I know my total has to be 4. So, and these have to be even, so my only option here would be 0 and 4, 2 and 2, or 4 and 0. All of those are going to add up to 4, so that would be my only possible options. So hopefully this isn't too long to get on YouTube. I'm going to stop it before I hit 18 minutes.